VX connector and metal-clad cable essentially describe the same thing. VX is a trade name, a specific brand name that has become a generalized term for armored cable. Armored cable, including what is commonly called BX, provides a protective metallic covering for electrical conductors. This metal jacket serves to shield the wires within from physical damage such as impacts, abrasions, and punctures. This protection is crucial in environments where the wiring might be exposed to such hazards. A metal jacket also provides a path to ground. BX cable consists of insulated conductors wrapped in paper and then enclosed within a flexible metal sheath. This sheath is typically made of steel or aluminum and has an interlocking design that allows the cable to bend without kinking or separating. The interlocking design of the metal sheath provides mechanical protection for the conductors inside. The metal jacket also acts as an equipment grounding conductor when installed correctly. The term connector refers to the fitting used to attach the armored cable to an electrical box or other enclosure. These connectors are designed to securely grip the cable and provide a reliable electrical connection to the box. Connectors ensure the continuity of the ground path between the cable armor and the metal box. The terms 12V-2 and 12V-3 refer to the size and number of conductors within the cable. The number 12 indicates the American wire gauge, or AUG, size of the conductors. AWG is a standardized system for denoting wire sizes, with smaller numbers indicating larger diameter wires. A 12 AWG wire has a specific current carrying capacity is determined by the National Electrical Code, or NEC. The numbers following the gauge size indicate the number of current carrying conductors within the cable. A 12V-2 cable contains two insulated conductors, typically a black wire for the hot conductor and a white wire for the neutral conductor, in addition to a bare or green insulated grounding conductor. A 12V-3 cable contains three insulated conductors, typically a black wire, a red wire, and a white wire, in addition to a bare or green insulated grounding conductor. The grounding conductor is used to provide a path for fault current to return to the source, helping to protect against electrical shock. These cables are commonly used in residential and commercial wiring for general-purpose circuits such as lighting and receptacle circuits. The ampacity, or current carrying capacity, of 12 AWG wire is typically 20 amps when used in wiring systems, but this can vary depending on the specific installation conditions and the type of insulation used on the conductors. The National Electrical Code, or NEC, provides specific guidelines for determining the ampacity of conductors under various conditions. When working with electrical wiring, it is essential to follow all applicable codes and regulations to ensure safety and proper operation of the electrical system. This includes selecting the correct size and type of cable for the intended application, using approved connectors and fittings, and properly grounding all metal enclosures. It is always recommended to consult with a qualified electrician if you are unsure about any aspect of electrical wiring. The next, specifically Table 310.15. B16 provides ampacity ratings for conductors based on insulation type and ambient temperature. This table is used to determine the allowable ampacity of conductors in various wiring configurations. For example, a 12 AWG copper conductor with type THHN insulation, which is a common type of insulation used in building wiring, has an ampacity of 30 amps at an ambient temperature of 30 degrees Celsius. However, the NEC requires that the ampacity of the conductor be adjusted or derated under certain conditions, such as when multiple conductors are bundled together in a conduit or cable. Derating is necessary to prevent the conductors from overheating due to the increased heat generated by the closely spaced conductors. The NEC provides specific guidelines for derating conductors based on the number of conductors in a raceway or cable and the ambient temperature. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and industry best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for anyone working with electrical systems to be familiar with the NEC and to follow its requirements to ensure safety and compliance. The NEC is published by the National Fire Protection Association, or NFPA, and is widely adopted by jurisdictions throughout the United States. Many local and state jurisdictions adopt the NEC as their legal standard for electrical installations. The NEC provides detailed requirements for the selection and installation of wiring methods, including armored cable. It specifies the types of connectors that are approved for use with armored cable and provides guidelines for supporting and securing the cable. The NEC also addresses the grounding requirements for armored cable, ensuring that the metal sheath is properly connected to the grounding system. Proper grounding is essential for providing a path for fault current and protecting against electrical shock hazards. In addition to the NEC, other standards and regulations may apply to electrical installations depending on the specific location and type of project. These may include local building codes, state electrical codes, and Occupational Safety and Health Administration, or OSHA, regulations. It is important to be aware of all applicable requirements and to comply with them to ensure safe and compliant electrical installation. When selecting connectors for armored cable, it is important to choose connectors that are specifically designed for use with the type of cable being installed. There are different types of connectors available for armored cable, including set screw connectors, compression connectors, and snap-in connectors. Set screw connectors use a set screw to secure the cable to the connector, while compression connectors use a compression ring to create a tight seal around the cable. Snap-in connectors are designed to be quickly and easily installed without the need for tools. The type of connector that is best suited for a particular application depends on factors such as the size and type of cable, the environment in which the cable will be installed, and the personal preferences of the installer. It is important to follow the manufacturer's instructions when installing connectors to ensure a secure and reliable connection. The NEC requires that all electrical connections be made in a manner that ensures a good electrical contact and prevents the connection from loosening over time. This typically involves using approved connectors and fittings and properly tightening all screws and terminals. It is also important to protect electrical connections from moisture and corrosion, especially in damp or corrosive environments. This may involve using waterproof connectors or applying a corrosion-inhibiting compound to the connections. Regular inspection and maintenance of electrical connections can help to identify and correct any problems before they lead to more serious issues. This may include checking for loose connections, corroded terminals, and damaged insulation. Any damaged or deteriorated components should be replaced promptly to ensure the safety and reliability of the electrical system. Electrical safety is paramount when working with electrical wiring and equipment. It is essential to follow all safety precautions and to use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Before working on any electrical circuit, it is important to energize the circuit by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to verify that the circuit is de-energized using a voltage tester before touching any wires or terminals. Never work on electrical circuits while standing in water or on a wet surface, as this can increase the risk of electric shock. If you are unsure about any aspect of electrical safety, it is always best to consult with a qualified electrician. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Proper planning and preparation are essential for any electrical project. Before starting work, it is important to carefully assess the scope of the project and to identify any potential hazards. This may involve reviewing blueprints, inspecting the existing wiring, and consulting with other professionals. It is also important to gather all the necessary tools and materials before starting work to avoid delays and ensure that the project can be completed safely and efficiently. When working with armored cable, it is important to use the correct tools for cutting and stripping the cable. A cable cutter or hacksaw can be used to cut the cable to the desired length, and a cable stripper can be used to remove the outer jacket without damaging the inner conductors. It is important to avoid using knives or other sharp objects to strip the cable, as this can easily damage the insulation on the conductors. When installing armored cable, it is important to support and secure the cable properly. The NEC provides specific guidelines for supporting armored cable depending on the size and type of cable and the distance between supports. Typically, armored cable must be supported every 4.5 feet and within 12 inches of any box or fitting. Straps, staples, or other approved supports can be used to secure the cable to the building structure. It is important to avoid over-tightening the supports, as this can damage the cable. When running armored cable through walls or floors, it is important to protect the cable from physical damage. This may involve using a conduit or sleeve to protect the cable as it passes through the opening. It is also important to seal any openings around the cable to prevent the entry of moisture or pests. The NEC requires that all penetrations through fire-rated walls or floors be properly sealed to maintain the fire resistance of the assembly. Fire-stopping materials are used to seal these penetrations and prevent the spread of fire and smoke. When terminating armored cable at an electrical box or other enclosure, it is important to ensure that the cable is properly secured to the box and that the grounding conductor is properly connected. The connector must be installed in a manner that provides a secure mechanical connection and a reliable electrical connection. The grounding conductor must be connected to the grounding terminal in the box, which is typically a green screw or a grounding clip. It is important to avoid over-tightening the screws or terminals, as this can damage the components. After completing the wiring, it is important to test the circuit to ensure that it is working properly and that there are no faults. A multimeter can be used to check the voltage, current, and resistance of the circuit. An insulation resistance tester, or megameter, can be used to check the insulation resistance of the wiring. Any faults or problems must be corrected before energizing the circuit. It is also important to label the circuit breaker or fuse that supplies power to the circuit to make it easy to identify and energize the circuit in the future. The label should indicate the purpose of the circuit and the area that it serves. Accurate and up-to-date labeling is essential for maintaining a safe and organized electrical system. Proper documentation of electrical work is also important. This may include keeping records of the wiring layout, the materials used, and the test results. This documentation can be helpful for troubleshooting problems in the future and for making modifications to the electrical system. It is also important to comply with all applicable building codes and regulations. This may involve obtaining permits, submitting plans for review, and undergoing inspections. Compliance with these requirements is essential for ensuring the safety and legality of the electrical installation. Remember that electrical work can be complex and hazardous. If you are unsure about any aspect of electrical wiring, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you to ensure that your electrical system complies with all applicable codes and regulations. Hiring a qualified electrician is an investment in the safety and reliability of your electrical system.